Hello my dears. So in this class we are going to discuss about overcurrent relays. Actually 3-4 classifications are there for overcurrent relay. So as the name indicate, overcurrent means basically whenever the current exceeds the set value of the relay or the predetermined value of the relay, then what happened? The relay will trip the circuit or the circuit will be isolated from the fault. That is the meaning of the overcurrent relay. So there are nearly 4 classifications of overcurrent relay. First classification is that instantaneous overcurrent relay, my dear. So instantaneous overcurrent relay means, suppose the set value of current is I0 here. The relay will be operate. This is time and this is I0 axis. This is I axis. The relay will be operate at the instant of the what? The preset value reaches. That we already discussed that there will be a pickup current. If the relay is operated as soon as or instantaneously, whenever the current in the coil reaches the minimum value of the current, pickup current is nothing but, my dear, the minimum value of current required to the operation of the required for the operation of the relay. That means for energizing the CT secondary, there will be certain amount of current. Then only the CT secondary will be energized and it will pull the plunger. That current is called pickup current. So instantaneous current relay means at the instant of when the current reaches the pickup current, it will operate and it will trip the circuit. And below that, there will not be any trip or any issue. And issue not trip, that's all, simply. That the diagram itself clearly indicate after this particular time it will trip and after it will not trip. And it's probably not independent of the time. Unless there is no time setting multiplier. If there is time setting multiplier, means the relay will operate only after a specified time. Unless the relay will operate as soon as the current in the secondary of the CT or the relay coil current reaches a specified value. That's all. Okay. Next one, definite time overcurrent relay. Definite time overcurrent relay. Definite time overcurrent relay. Here, my dear, as the name indicate, definite time overcurrent relay, this is this one. Definite time overcurrent relay means we have to obtain or we have to satisfy two conditions. First condition is that the current in the relay coil greater than the pickup current and the fault current exists for a particular duration. The fault current exists for the particular duration. Then only that type of relay will be operated. Okay, that means, my dear, suppose this is the graph. I can show that this is I. Not only it reaches I0, it should be exist for I1, it should be exist up to T2, then only there will be a trip. I will explain now. So definite time overcurrent relay means, my dear, the relay should not operate instantaneously when the fault happens. See, there are many type of faults are there. One fault should be, it like to be, there will be fault for very short duration. If it doesn't affect the system much severe, then that fault can be simply neglected. But if the fault exists for very long time, or some millisecond or some seconds, the stability of the system will be affected. So that type of fault should not be there. So that we can't use instantaneous overcurrent relay there. That if the fault is there for some time duration, after that only the relay should act, means we can use definite time overcurrent relay. If you are using simply what instantaneous overcurrent relay means, at the instant of fault itself it can operate. So what is the problem there, my dears? What is the, sir, you should ask me, my dears, array sir, what is the problem then? You can instantly switch off, no problem na. His problem is there, reliability of supply will be there na. Reliability of supply will be there. If whenever a problem is happen, you switch off the supply, you trip the coil, reliability is there? No, there is no reliability. For getting reliability, what? You have to observe, okay, fault occurred, okay, is that fault affect my system? When it affect my system, that fault exists for very long duration. If the fault is cleared after some time, then we don't need a relay na. We don't need a relay. So definite time overcurrent relay means we should condition to be satisfied actually to the current in the relay coil should greater than the pickup current, then only the relay will operate. And not only this condition, but also the fault can exist for at specific duration, say 3 millisecond, 4 millisecond, 5 millisecond. If the fault current exists more than 5 seconds, array, the relay will go, relay, you just trip, you can send the message. Otherwise, you have to wait until the fault clear in specific duration of time. If doesn't clear, means you can trip your relay. That is the meaning of definite time overcurrent relay. See, my dears, for examination point of view, just you need to know the basic theory, that's all. They won't ask any big circuit diagram for this and this. No one will ask you. For examination point of view, I am taking, it's more than sufficient, I think. Okay, after that you complete your relay. You just take to solve the previous year paper. If you can solve, then our method is correct. Our study is enough. That's all. Our study is enough. That's all. Is it clear? So that is the concept of what, my dear? Definite time overcurrent delay. Next one. Next one. It is directional, okay, inverse time relay. Inverse time relay. Inverse time relay, my dears. So as the name indicate, my dear, as the name indicate, when I versus T graph, it follows the inverse curve. That means whenever the fault current is higher, the action should be with very few time. Whenever there is a fault current is low, it can take some time. Is it clear? That means a heavy fault current is observed, means the relay should act quickly. The relay should act quickly when the current is very high. If the current is very low, means it can take some time to act, no problem. That type of relay is called inverse time relay, my dear. Or in that, there are again further classification. This is inverse time. I will show here. This is inverse time. This inverse time. Inverse time relay. This is very inverse time relay. This is extreme inverse time relay. Inverse time delay. You can classify accordingly. Just as a theory point of view I am taking. This is I against time. That means the inverse also can be very inverse or extreme inverse. According to the slope of the graph, you can vary that. That's all. That is not that much important. Just inverse time relay means the time of operation is inversely proportional to what? The question may be like this: current, voltage. Here it is current, that's all. Here it is current, that's all. So that is inverse time relay. Next one. Distance relay, directional overcurrent relay. Next one. Directional overcurrent relay. So the relay is same as that of the definite time relay, except one more thing you should add here. That is nothing but the conditions. Conditions I will write. Conditions. First one, the relay current greater than the pickup current. Condition number 2, the fault exists for a specified duration and third condition is, that's very important, the relay should be directional. If these three conditions are satisfied, that means the direction also you added. Direction, one term is directional also you added in the definite time relay, you will get the directional overcurrent. That's all. Directional overcurrent relay, that's all. Okay? Is it clear, my dear? Is it clear? So that's all about the overcurrent relays.